hydrogen and
So
separation.
potential candidate for employment and fellowship earlier.
Yeah.
Yes, please.
Good afternoon, everyone. I am Suham Kumar. I am working on topic graphene oxide, its scale-up kinetics studies. I am working in glass and advanced material division.
Good.
I am in second year of PhD.
Second year.
Yes, sir. Under Kinsuk Das Gupta, sir.
Good evening, sir. My name is Amrit Kapoor. I am DDFS PhD student, currently first year. I am working on separation of immiscible phases using radiation resistant and super hydrophobic membranes
Okay.
and in CHED division.
Separation. Super hydrophobic membranes.
Good afternoon, everyone. I am Sachin Maharshi, DDFS first year student, and I am working on fabrication of electrode materials for solid oxide fuel cell under Amit Sinha.
Okay. SOFC.
I am Vaibhav Patel, first year DDFS PhD student, and I am working in study of deformation and fracture behavior of low alloy steel as a multi-phase microstructure using miniature test techniques under Dr. Chiradeep C. Gupta sir in MMD division.
Which alloy? Not yet decided. Which alloy?
RPV steel,
Steel. Okay.
PV steel,
Get preservation.
low alloy steel.
Good evening, everyone. My name is Sheikh Taslim Ali. I am a third year PhD student of HBNI, and I am working in the title of doping and functionalization, carbon nanostructure, and their interaction with other molecule. And I am working with Dr. Kinsuk Das Gupta, sir.
Okay. With Das Gupta student. Yes, please.
Good evening, everyone. I am Shagnik Mitra. I haven't yet started working, but I will be working under Dr. A.K. Tyagi, sir, on photocatalytic reduction of carbon dioxide.
Okay.
Good evening, sir. My name is Anand Kumar, and I am working in health monitoring of nuclear reactor using acoustic emission sensors in our department.
AE sensors.
Yes, sir.
Good evening, sir. My name is Deep Singh. I am DDFS first year student. I am working on membrane-based CO2 capturing.
CO2 capturing. Fine. This side. Yes. No, yourself. Yeah.
Good evening, sir. My name is S. Jayagomati. I'm DDFS first year student, and I'll be working on study on densification mechanism of high entropy borides, and I'm on MPCAD division.
Okay. High entropy borides.
Good evening, sir. My name is Rita Sarajoj. I'm currently first year DDFS student. I'm working in RPDD division under Dr. R. Karthikeyan. My work is mainly on calculating resonance absorption using methods of characteristics or tones method by using a code called diamond.
Okay. Fine.
Good evening, sir. My name is Anshuman. I am working in synthesis of high quality 3D graphene by CVD method and further modeling for membrane applications under Dr. Kinsuk Das Gupta. I am third year DDFS PhD student.
Okay.
Good evening, sir. I am Anshuman Sharma. I am currently in third year of PhD. I am working on design of new internals for pulse column. I am working in chemical engineering division.
Okay.
Good evening, everyone. I am Manish Singole. I am working on hydrogen storage in chemical hydrides, and I am third year PhD student.
That is Professor Naveen Kumar. We can also. Associate Dean Engineering.
HBNI, Engineering Sciences.
Thank you. Speak louder, otherwise. Oh yeah, online, no? So you can use the mic.
You can come forward.
My name is Bristisnata Kashyap. I'm a third year PhD student, and my topic is synthesis and characterization of electrode material for alkali metal ion batteries. And I'm working under Dr. Dimple Datta in chemistry division.
Okay. Yeah, alkaline batteries.
Good evening. I am Reshmi. I am working on the topic titled as Defect Engineering in Multifunctional Materials for Targeted Application, and I am working in Radiochemistry Division.
Morning to all. I am Anu. I am third year PhD student and I am working on the development of luminescent materials for solid state lighting and bio application.
Okay. With whom? With whom? Guide.
Dr. Santosh K. Gupta.
RCD.
Mike, because online. Yeah.
Good afternoon, everyone.
Okay. Okay.
Come here. Morning all. My name is Virendra. I'm doing on synthesis of anion exchange membranes for fuel cell applications under the Department of Desalination Membrane Technology Division under the guidance of Hemant Sode, sir.
Okay.
Joshi, I work for a small angle neutrons scattering for characterization of subconductor matter.
Fine.
Now my advanced nuclear reactor and I my third year of PhD. The title of my PhD thesis is Carbohydrate Based Drug Release Systems, and I'm working under Dr. Atan Bari.
Chemistry division.
Yeah.
Good evening, everyone. My name is Naman Kumar Bhatti. I am doing
Pramod, sir.
computational studies on small molecule activation
Very nice.
under Chandranath Pata
Register.
in ACDDV.
Good evening, everyone. Third year PhD student. I'm doing my PhD in composite based gas sensors, and I'm currently in third year of PhD. I'm in class and advanced material section.
So over. Yeah.
Atomic and molecular physics division.
More. Okay. Yeah. Oh. There are some more chairs. Eh? Yeah. Meiti, you can start. No?
Okay, I'll start.
Welcome and then.
Hey everyone.
Let's
My name is Deepika Kumari.
go on.
And I am doing my PhD under Dr. K. Tirunelveli.
Okay. Naveen Kumar.
Good evening. Tariq from physics group. I'm doing PhD under Dr. Mala Rao on hydrogen and experiment.
Okay, I think. Okay, good afternoon, everyone. Welcome, my dear friends. This is by HBNI Industry Linkage Center. We are organizing many programs so that students come to know what is going on in industry and what kind of research work there in the lab, how it can be really used in the industry scale, or what they want, industry people, what they want out of you. So for that, we started, some program that you can spend some time up to 6 months in an industry as an intern, which is apart from your whatever the PhD program duration, 5 years, so plus 6 months one can do that. And during that period, you will get most of you will get a fellowship, and there is a possibility of getting even job opportunities. So far we have succeeded with 2 students. Recently, they joined Tata Motors. Tata Motors, right?
Tata Steel.
Tata Steel. Sorry, Tata Steel. So that was the purpose. Then again, we had got the options that about 5 to 6 chemistry students can be adopted for 6 months in industry. We tried to look for such applications, but we failed. Probably nobody could apply. Probably they don't know whether it is going to be useful. They don't know that whether they fit for the industry. So to remove all such your concern, we thought of talking to arrange a lecture, none other than Professor Joshi, J.V. Joshi, who has long interaction with the industry. As you know, he was former director also. He's our district professor in HBNI for long. He has been working. Many PhD students from HBNI got PhD degree under his guidance. And he has a long collaboration with industry. So he knows exactly what industry wants out of you and how your knowledge in the laboratory can be used in the industry. So both way it is useful. So we requested him, and we are very happy that, sir, you have accepted our request. And not only that, he has come, and 2 more persons like Professor Vange. He is also having industry collaboration quite some time. He is also professor in chemistry department of ICT. He is a chemical engineer. And another person from industry, Dr. Ajit Sapre, who is vice president of Reliance Industries. At present, he is in abroad. He will also talk to you from abroad. So these 3 lectures, how means probably you will be enriched with the things at the end of the day, that what they need and what you are gaining, how it can go hand in hand. So with that, I request our Honorable Vice Chancellor to start. Just give it to
Good evening, Professor J.B. Joshi, distinguished professor of Professor Emeritus of HPNI, Professor Balchandar Banage from ICT Mumbai. Dr. Ajit Sapre will join online. My senior colleagues from HPNI and my dear students. I will only add on to what Professor Methi was telling. The new education policy of the Government of India, it encourages students to go for internship in industry. Earlier people were thinking that, only the undergraduate engineering students, they'll go for a 3-month or 6-month project work and they will come back and submit some report. That was done in a ritual way, in a routine way. Now this new education policy is insisting that all those students who are studying anything and they feel that as part of their degree program, they should go to the relevant industry and spend some time to understand how their research is going to be useful there, or how their research will contribute, to the industry, or how the research that is happening in industry, you can fine tune your research so that it will match with the industry requirement. This is not only internship to industry. Even somebody is interested in doing anything artistic, you want to, to understand some traditional science, traditional engineering, like, sculpture that, schools are there, some traditional schools are there. If you want to go and study for 3 months, universities should encourage and make those students to go there and do that. And maybe that you will give some very good idea and innovation to those people, so that their level will increase, their marketing potential will increase, or that you can get some very good input that will be helpful to your study, and it will broaden your knowledge about the Indian knowledge system. So all this is, encouraged in the new education policy. So in the last 10 months, we have been pushing this intensive program. And soon after I joined that, we have reactivated this Industry Linkage Center in HPNI. And we have requested the students to provide the internship application. In fact, we received a large number of applications, and we have made a circular to all the institutions, to all the guides, to encourage the students to do internship. Now, there are certain questions that suppose I am going for internship, what will happen to my work? And whether that work will be part of my PhD, and whether I will get fellowship there and fellowship here. Okay, so Dr. Maiti is the chairman of the implementation committee. You can anytime contact, not only now, anytime later. But basically that the period for which you are going for internship, we are trying to get fellowship from those industries. For example, now two students are going to Tata Steel. Tata Steel is paying 60,000 per month as internship. And then this gives an opportunity that, for example, they are working on, let us say, some ultrasonic imaging technique. And that industry, Tata Steel, is interested in knowing these students' skill and capability. And they are also doing ultrasonic imaging for their product, actual product in the industry. So now the student will go there and he will spend time, and he will try to, either he give his knowledge input to them, or he may get, additional knowledge that how my research, what I have done in the ultrasonic imaging, can be adapted to industrial purpose. Then only there is a linkage. Otherwise, you do PhD, you publish paper, present in some conference, and then you forget the whole thing for the entire life. So this may not be every time now you use the same, the PhD work in your PDF or in your job. But this is an opportunity that you can go to the right industry where your, knowledge is required there. And there is a potential chance that Tata Steel may absorb the person after 3 month or 6 month internship. They may offer him. So we have requested like this many industries, and industries are willing to take. Okay, so your fellowship for the period, we are encouraging students from third year onwards. Once you start working after your OGC is completed, third year onwards you should be, trying to do some kind of going to industry. Suppose you go and come back. Let us say you are a chemical science person making some synthesis. You go to some industry like Reliance. You understand how they're, operating their, the pulse column or, reactors, how they make large scale production. Then you will have a knowledge that whatever I am synthesizing here in the laboratory with a flask of, 50 ml, 100 ml, how that can be scaled up, all that knowledge it will come in your mind. So that is going to be a holistic education where academics will be blended with research and industrial application. So third year onwards, you should try to do that. But this should be done in consultation with your guide. Your guide should be willing to, relieve you for that period. Minimum 3 months, maximum 6 months. Okay, there are two options here. You can identify industry on the topic you are working. You can write to us. Second thing, your guide can encourage you to go to some industry where he has contact, where he feels if you work 3 months, come back, it will be useful here. So these both options are there. So you come back, and suppose the work that you are going to do there is going to be relevant to your thesis with the permission of the industry. You can use it in your thesis, of course, with the permission of your guide and dean academic. So we have, if you go to our website, HILC, you click it, you will see this form. There is a form, application form, where we are telling also that what is your background information. Then we ask what are the skill set you have for which you go on to go for internship. Right? For example, it is applicable. Suppose I am very good in Python programming. I want to go to this industry. I can do some software development for them. So that will be a very good thing. So you do some industrial solution there. Okay, so you write all your skill set, what you have. Okay, so accordingly, the industry will study that and then try to choose you. And second thing, that it has to be routed through your guide and the dean academic or the dean of the institute, that they permit you to go for the internship. Once we receive this application, we consolidate. And if you have mentioned that I am interested in 1, 2, 3 industry, with your permission of your guide and dean academic, we will send to those industry. We will try to help you. Okay. Ultimately, respective institutes will do this. But right now, since we have started, we are trying to push this. So you understand this is the concept of internship. Now somebody can ask me that why this particular meeting to only chemistry and chemical science and chemical engineering. Our professor, distinguished Professor Emeritus, Professor Joshi, all of you must know that he has instituted an endowment in HPNI, and more than, I think, nearly 30 lakhs of money, cash he has donated to HPNI. And we are giving JB Joshi Innovation Award for the best PhD thesis. And we are also organizing an endowment lecture every year during the Foundation Day. I hope that senior people would have got this, those who are submitting thesis, this detail. It is also in the website. Now, Professor Joshi is, told us that I can sponsor 5 students who are interested in doing this internship. I can place them in industry. I can place them in the place depending on their project work for 3 or 6 months. If the student is willing to come, the guide is accepting or something. So when we are looking for chemical science, engineering and technology students, we were not getting any single response. So there is some gap. There is some kind of, it's not that nobody is willing. There is some gap. There is some kind of a clarification needed for the students as well as for those faculties who are associated with chemical science, engineering and technology. So we felt that we should have one workshop, and that is where the origin of this workshop started. Career opportunities in industry for chemistry and chemical engineering doctoral students. At the same time, under NEP 2020, the Government of India, Ministry of Education, you all know that Viksit Bharat 2047 government has instituted. By 2047, what are the things that we should achieve? So under that, they have also asked us that we should conduct a program with a theme employment opportunity. Okay, so we synergized all this workshop and this Viksit Bharat requirement. So we felt that we'll have this evening program. We have 3 eminent speakers. One is Professor J.B. Joshi himself, and Professor B.M. Banage, and then Dr. Ajit Sapre. So for your information, the program will start with first lecture by Professor Balachandra Banage. He is a professor of industrial and engineering chemistry and head of Department of Chemistry at Institute of Chemical Technology. He is an eminent professor there, and he did his PhD in 1996 at University of Pune in NCL Pune, and he has been at NCL. He has been a JSPS fellow at Tohoku University Sendai, and he was a Crest fellow in Hokkaido University Sapporo. And since 2004, he is professor at ICT Matunga. He is a fellow of Royal Society of Chemistry, Biotech Research Society of India, Indian Chemical Society, and Maharashtra Academy of Sciences. He has guided so far more than 50 students for PhD, and currently some 12 students are working with him or PhD. And he has publication more than 460 papers, and his total citation is 19,580 as on date, with a H index of 71 and I-10 index of 376. He is listed in the top 2 scientists in the world as per analysis published by Stanford University, USA, in the subject organic chemistry since 2019. And he has received the prestigious Dr. Garda Award for contributions in research by USCT. He has received a bronze medal for the contributions in research by Chemical Research Society of India. He has received Professor M.M. Sarma Science and Technology Award, several other outstanding awards in the field of chemical sciences, and he is an associate editor of Catalysis in Green Chemistry Engineering Journal, published by the Beagle House in USA. The section editor of Indian Chemical Society Journal is published by Elsevier with an impact factor of 1.3. Secretary of the ACS India International Chapter, Chairperson of Catalysis Society of India, Mumbai, and he has done several outreach activities in chemical science for the Maharashtra Vidyan Parishad to popularize science under the leadership of course, Professor J.B. Joshi. And he's basically a chemical engineer, and he is teaching. Bachelor of Chemical Engineering, BTech Organic Chemistry, Inorganic Chemistry, Industrial Inorganic Chemistry. He is also teaching for MTech Green Technology. catalysis science and technology, and MSc chemistry students is teaching organometallic chemistry, materials chemistry, industrial and engineering chemistry. I'm very proud that he has accepted our invitation, and he will be speaking about 30 minutes on the opportunity for PhD students in industry. The next speaker, of course, we don't need introduction, but for the younger people who are here, I will tell you, distinguished Professor Emeritus, Professor J.B. Joshi, is also an adjunct professor at Department of Chemical Engineering, Louisiana State University, USA, and also Curtin University, Australia. He was the former director of ICT, 1999 to 2009. During his tenure, ICT was converted as a deemed to be university, and he was the first vice chancellor. And he is a Padma Bhushan by the Government of India, honored in the year 2014. Shanti Swarup Patnagar Prize winner in Engineering Science in 1991. Eminent Engineer Award from Engineering Council of India 2018. J.C. Bose Fellow of DST 2008. Lifetime Achievement Award from Indian Chemical Council in 2008. Fellow of all the Indian Engineering as well as the US National Academy of Engineering, USA. He has more than 52 years of research and teaching experience, maybe twice that of your year age. And he has been research and teaching interests is fluid mechanics, multi-phase reactor design, computational fluid dynamics, atomic energy, solar energy, and bioenergy. He has guided more than 115 students, 60 masters, 34 postdoctoral, and right now I think 10 students are ongoing. And he has developed many new and novel processes, designs, products, and implemented in large, medium, and small scale industry. And all of them, most of them are successful in commercial operation. And as a president of Marathi Vinyan Parisad, he has been, sustained manner, he is promoting the application of science in agricultural productivity, water balance in rural areas, and development of technologies. He has published nearly 650 papers in journals, presented more than 125 papers in conferences, and more than 50 papers in conference proceedings, and state-of-the-art review monographs 100 plus. His Google Scholar citation is 28,660 with a H index of 84. I'm very proud that Professor Joshi will be delivering about the career opportunity for chemical engineering and technology for about 30 minutes, followed by this lecture by Professor Banage. The third speaker, who is presently in US, he will be joining. It's early morning there. He will be joining later. The third speaker, Dr. Ajit Sapre, and he received his PhD from the University of Delaware and MBA from Cornell University, USA, and Bachelor of Chemical Engineering from UDCT, Mumbai. He has more than 40 years of experience in the petroleum refining and petrochemical business, technology development, and management. And his experience includes technical and managerial assignments in research engineering, business, manufacturing, and corporate planning. He has experience in upstream oil and gas, downstream refining, petrochemical, polyester, lubes, and renewable energy sectors, and published more than 100 technical papers, 1 book, 3 book chapters, and more than 200 worldwide generated granted patents, more than 200 patents international. And he has, in this number of US patents, is 50 out of 200. He is currently the group president, Reliance Technology Group, Reliance Industry in Mumbai. He will be the third speaker. So I'm very proud to welcome all of you. Feel free to attend these all three lectures, and please note down all your questions. In the end, we will have brainstorming. You are most welcome to ask any questions. Professor Banage and Professor Joshi are available here. Time is no limit. You will get good snacks, I feel, in between. So spend your time, valuable time. Those who are in the first year, you can dream about what job you can plan for future. Those who are in the final year or fourth year, you should immediately catch up and take advantage of the eminent people here for your future career. I welcome all of you. Thanks a lot for joining. We will join with Professor Banage. Push it, little push it and sit here. Turn this side, na? Just pull it here. Bring it here. Be comfortable, push it. You want pull it here. Pull it here.
So Honorable Vice Chancellor Dr. Kamachi Mudli, Honorable Professor J.B. Joshi, Professor Tyagi, staff of the HBNI, and dear students. It's my pleasure to be here. And I was listening to your introduction. What I find that you should not worry about your job prospectus in industry, looking at the topics on which you are working. These are all highly advanced topics, and currently research is required in these areas. When I try to relate your topics, most of them are related to material science, nanochemistry, hydrogen storage, electrical battery storage, CO2 utilization. These are all advanced research areas, so you should not worry about your career. I can see that you have very bright career. So why I am here? Yes, to tell you what is required or what is going on in the chemistry area. And chemistry and chemical engineering, there is always a thin boundary. You cannot distinguish science and technology by boundaries. But what is important, the language of chemist and chemical engineer, they should know each other. So the way you are doing your reaction, particularly chemist, most of them are doing reactions in round bottom flask with Teflon needle, which is not reproducible at higher scales. Naturally, you need a agitated stir reactors with precise temperature control, and then only you can scale it up. So such small things are very, very important while doing the experiments. And therefore, language of both the worlds should be necessary. So today I will talk about careers in chemistry. First part, I will see that where the chemistry is there in our day-to-day life, followed by what you should do about yourself so that you will understand the need of the hour, how you can improve yourself. And in third part, we will see that what type of job professions are available for the chemistry. So all these three sections will be there in my talk. This talk is a general talk given to school children to the PhD students. So some slides you may feel that it is too simple. Please bear with me. Today we have seen all this development, and it is all because of the advancement in the chemical sciences. And without advancement in the chemical sciences, we could not have seen such development. It can be in the field of telecommunication, like right from handsets, healthcare, food industry, vehicle industry, energy sector, everywhere chemistry is required. And of course, all this chemistry from lab scale, chemical engineers will do the job to take it to higher scale. I am showing such slide because although you are doing research in your niche area, you should think about other areas also where you can correlate all these things to your research. For example, chemistry of flower. If you smell the flower, you will come to know what type of molecules are there. Whether I can mimic this in the lab, whether I can synthesize in this lab. This gives you many kite flying ideas for your work. In home, all the kitchen chemistry, it's whatever the activities you are doing in kitchen, you can easily correlate with all the activities in the lab. Right? Everything in the home is a chemistry. It can start from shower, wallpaper, baked bean, Teflon. Teflon is discovered by accident. So why this is important? Because when you are doing your experiment, you should be very much observant to what is going on. Most of the inventions were happened by the accident. You look at the history of the Nobel Prizes in the chemistry. Many of them were serendipitous inventions. And why they happened? Because they were observant. they try to probe further why this was happening. Paints, again, it's a chemicals. And you know that today there is a requirement for matte paints, non-drip paints. Even people are thinking of color changing paints with respect to temperature or with respect to many other parameters. So research is required in this area. So you have to improve the performance like computer parts, sports equipment. You are already working on carbon nanotube and you know the importance of carbon fibers. So all that can replace the sports materials very easily. Better flat screen displays. All flat screens today we have seen it is all because of the development in the OLED fields. So you are aware about all these things. Even art, modern masters. Today you don't need oil paint and do canvassing. Just by the digital media you can do the art. That is also possible with the help of chemistry. Right. So those who have hobbies of doing painting or something, now they can use digital media to do the painting. Photography. We started from silver film. Now today we are coming to the digital image. But finally, digital image, if you want to print, you need color printer. And color printer needs dyes. And dyes should be reproducible to what they look like. So there is a challenge to maintain the shades. So research in this area is also very, very important. How to prepare dyes with specific shades. As I had mentioned to you, cooking is a chemistry. You observe all your processes in your kitchen, you will find that chemistry is there. Even if you want to have food fresh, chemistry is involved. What is the chemistry in keeping the food fresh? Food industry, suppose you look for, what is required there? So reaction of food with oxygen should be stopped. So quite often we put blanket of nitrogen. Your vapors, you have seen that they are containing nitrogen blanket. So whether you can develop alternative techniques by which you can cut off the oxygen. So there should not be use of gas there. There are many ways you can think research is required. Ice cream has lots of physical chemistry. You may not be aware. It has surfactants, it has ice, fat, air. It's just a mixture of these components. But challenge is keeping ice cream in solid form at maximum possible temperature. There is a challenge there. Energy sector, all of you are already working. Many of you are working in green hydrogen or electrical storage. So energy related sectors has lots of potential to do research, particularly batteries, cleaner sources of energy. You are already working on CO2, how CO2 can be converted into valuable chemicals. Again, a very important catalysis will play significant role there because highly oxidized carbon converted into reducible form is a challenge. And as a PhD student, some of you are already working in this area. You should think how it can be economical. Having publication and just showing that carbon can be reduced has no meaning. Whether it can be economical, and that is what industry is looking for. If you come out with a solution in which you can reduce the carbon with energy efficient way, economical way, lots of scope is there for carbon utilization. Petrol. Let me tell you, although we are talking about solar EVs and many things, petrol will not go for next 100 years. Petroleum and petroleum product will always remain a part of our transport sector as well as chemical sector. Oil to chemical area is growing, and you can see that in future, all this crude oil will go to the oil to chemical sector. Finally, source of chemical will come from petroleum sources. All aromatics will come from the petroleum sources. So research in this area should not be stopped. Petroleum products, developing the suitable catalyst which can convert the cracking or many other processes in the petrochemical industry. Again, lot of scope is there. Green chemistry. And we have seen that earlier days we used to have dirty labs, smell is coming. Today it's not like that because more energy efficient and cleaner processes are coming up. You have seen that catalytic converters developed in the car. Today we are going for Bharat Stage 6, in which there is no toxic gases coming out of the vehicle because we have good quality catalytic converters attached to the fuel engines. So again, green chemistry will play a significant role. You already know that green chemistry journal having impact factor more than 10. Many energy sector or green chemistry related areas having lots of scope for doing the research. Are followed by hydrogen. Again, hydrogen storage and delivery of the hydrogen for transportation sector is a challenge because hydrogen storage materials, even today, it's not at the level at which we can think of commercialization. So there is a scope for hydrogen storage material. Organic farming. Again, developing a fertilizers which will be environment friendly because they should not develop or damage the soil. So whether you can develop organic farming related fertilizers, again, there is a scope to do that. Fashion. Our day-to-day life starts with toothpaste, and toothpaste is nothing but our chemical formulation based on peroxide. Whether we can replace with safer concentrations of peroxide with longer life of peroxides. Still, lots of challenges are there with respect to fashion, self-cleaning clothes, shampoos. Research is going on all these areas. Synthetic dyes, just now I had mentioned that. In between, there was a news that some dyes were banned because they were carcinogenic. Because when they get degraded, the degraded components were carcinogenic. So, whether we can develop a dyes, even after degradation, degradation products are not carcinogenic. Still scope is there in this area. Medicines, all of you know that medicines, without synthetic organic chemistry, you cannot have active pharmaceutical ingredients, and you can do research in this particular area. Cure for cancer, AIDS, still research is going on. We have not found the effective solution for that. So again, there is a scope to work in this area. Asthma drugs, developing good aerosol formulation, which can take the drug to the site is again a very important thing which one can develop. Biochemistry again plays a significant role while developing all these technologies. Body chemistry, one need to mimic what is the happening in the body reactions, enzymes particularly. You know that the reactions which we are doing at harsh condition, body is doing at ambient condition with water as a solvent. So why not mimicking the nature and doing the reaction at the atmospheric pressure and water as a solvent? For that purpose, you need to study the body chemistry, developing enzymes which can be effective. That is possible. So chemical science is, of course, important to all of us. And you have already joined the PhD program, and you can see the scope for the chemistry as such with respect to the research. So let us learn some typical branches of the chemistry. All of you are doing PhD, and you should not forget that analytical chemistry plays a significant role in your chemistry. Many of us are not doing why to do GC and why to do HPLC while analyzing our samples. When to use GC, when to do HPLC. What type of detectors are present to the GC and what type of detectors are present for HPLC. You should be curious to know how they function. When you go for the job interviews, they will ask you such fundamental and basic questions. Many of us are not knowing all these things. We are just using the machines as such. For that purpose, my advice to all PhD students that read and try to learn the fundamentals behind the instruments which you are handling. Don't use them just like a black box. Try to understand the fundamental. In old days, we used to create our own instrument by purchasing the separate parts. We used to do our own glass blowing. Your generation is that way lucky because you are getting everything ready-made. All the instruments are ready-made. You are not assembling your own instruments. When you assemble, you will come to know the importance of each and individual part of the instrument. And analytical chemistry, so job opportunities are there in analytical chemistry. Even if you are a PhD, many pharmaceutical industry requires analytical chemistry. Developing method of analysis. So there is a lot of scope for analytical chemistry as such. Although you are doing PhD, this branch should not be ignored. This is always considered as a supportive branch to main activity. Some production is going on, you have to analyze the products. In research also, you are doing some reaction, analyze the component. So importance of this branch is always shadowed because of the main activity, but this is important. And as I mentioned to you, analytical chemistry has lots of scope in industry to do the jobs, different jobs. Automation. Now, although I had mentioned to you the importance of instrument building, you should also aware about the what type of automation is going on, how auto sampler works, how to put the sample in the auto sampler. Because in industry, you have to analyze thousands of samples within a day. And if you don't know how auto sampler functions, it will create problems. So you should know what type of problems you can encounter while handling the auto sampler. Auto sampler can be in many instruments. For example, it can be GC, it can be NMR, it can be HPLC. So you need to develop specialized knowledge or hands-on experience while handling all these machines. Then analytical chemistry, not only doing the analysis, but it also has a legal process. Keeping valid documentation is also very, very important while working in the industry, because lots of audits were going on and they will take the trail of all your analysis. So you should be particular about keeping the records while doing the analysis. Biochemistry I had mentioned to you just now. It has a scope to do lots of things, particularly solutions for the molecular biology, bioinorganic, and food sector. Many places biochemist will play a significant role. Food science will have another area in which biochemistry will play significant role, because unless and until you understand the reactions of food science, biochemistry based is very, very important. I don't know how many of you are working in biochemistry area. Many people think biochemistry has a limited scope. It's not like that. Many industries are there, and particularly in food sector, biochemistry has a significant advantage. Agriculture, pharmacology, physiology, microbiology, toxicology, clinical study. Many of us are not aware that how MHDS is generated. And MHDS plays a significant role while handling the chemical. All of you are aware about MHDS. And for that purpose, toxicological data is required. Toxicologists are not there. That field is having tremendous scope. If someone is doing toxicological studies, it has immense job opportunities. How chemical functions or what is the toxicity of chemical. It's a very, very important field in which one can think of doing the career. Inorganic chemistry is a mother branch. All of you know that all the branches were derived from inorganic chemistry, and probably you may not be aware that our mobile phone has 82 elements from the periodic table. All the inorganic chemistry is there in your hand. Now, what is scope? What is so special? Suppose you are doing inorganic chemistry study and we don't have enough resources on the earth to get all these 82 elements required for the mobile. We are using this from the future generation. So we should develop a technologies by which we can recover all these elements and reuse it. So today there is a need to develop waste management technologies, and particularly in electronic sector, so that inorganic chemistry knowledge will play a significant role there. How one can recover the metal. And of course, as a nuclear scientist, you are already aware how to recover the metal. So that knowledge you have to extend it for the other metals. PhD is a training about how to do the research. It's not the only study of that particular problem. What you will gain, how to design a problem, how you will find the literature, how you will solve the problem. That is the objective of your PhD. Same knowledge you have to apply to the different solutions. So don't confine that you know only the hydrogen storage or you know only the CO2 field. It's not like that. It's a training about how to do the research. So same way, inorganic chemistry, I said, electronic waste management, knowledge of inorganic chemistry will play a significant role. And you should consider about this particular area. Industries are now coming up. Many startups are coming up on inorganic based knowledge. Again, as far as MSc is concerned, if you look for the admission, 90% goes to the organic chemistry, 10% goes to the inorganic of the analytical chemistry. No one bothers about physical chemistry and inorganic chemistry. They are equally important. Now, specialists in all these fields are equally important. They have jobs in industry and people are not there. So if there is a good physical chemist, good inorganic chemist, job opportunities are there. And you will find today job market is flooded with the organic chemists. And there are not enough space for them to all of them will get a job in industry. So I can see that there is a scope in other branches. So one should think, although you have already defined your problem, it doesn't mean that you should not look into these things. In future also you can work in these areas. So if you wish, I will share this presentation with all of you. You can read it. I will just talk. So you need not read it. Ammonia synthesis, chlorine, titanium dioxide, important materials. Again, requires research to develop clean and green methods to develop. Ammonia synthesis even today needs lots of research. You can see single atom catalysis research is going on in the ammonia synthesis. You look at the ACS Catalysis Journal, you will find series of papers are coming up in the ammonia synthesis with single atom catalysis. Tremendous scope is there. Chlorine, titanium dioxide, again, very important material used in pigment industry. Organic chemist, I need not mention, there are many organic chemists and it is an important area. You can design the molecule, you can synthesize the molecule. So what is required there? In organic chemistry, what is required? Whether you can bring down multi-step synthesis into few steps. And for that purpose, catalysis will play a significant role. And there is a challenge here. You can synthesize any molecule, work will not get published into the good level journal because it is a known art. Unless and until you show that this is a new route which I have developed, or I have condensed the steps from 10 to 5, or I have developed a very high atom economy, publication will not get into the good quality journals. So organic chemistry has a scope, but synthesizing just a molecule, again, it has no novelty. Now, what is required in organic synthesis? In pharmaceutical industry, today there is a lack of chemists who can do the multi-step synthesis. And we are not finding manpower who can do the multi-step synthesis. So those who have interest in organic chemistry, if you can do multi-step synthesis, many jobs are awaiting for many jobs. You should able to do the multi-step synthesis. Why? Because all the drugs are today manufactured with all this multi-step synthesis. And what pharmaceutical companies are doing, they are taking off patent drugs, and once that patent, that drug goes out of patent, they flood the market with that particular drug. So manpower is required in this area also, although plenty of manpower is already available. And as I mentioned to you, organic chemists, crop protection, agricultural, pesticides, biofuels, everywhere organic chemists are required. Consumer products, again, organic chemistry plays a significant role. Organic industrial chemistry, again, plays a role in rubber, plastic products, textiles, petrochemical refining, pulp and paper, primary matter. All these industries, you will find the organic industrial chemistry. Petroleum sector also, you will find the organic chemistry, particularly now oil to chemical sector is emerging. And in oil to chemical sector, how you can develop different types of chemicals from the oil, organic chemistry knowledge will be useful. Pharmaceutical, as I mentioned to you, it is based on the organic chemistry-based synthesis knowledge. In government sector also, you will find in food and drug administration organic chemists to evaluate the pharmaceutical industries. Physical chemistry is another important branch. In 60s or 70s, there was a really craze for physical chemistry. First branch which used to close is physical chemistry, followed by inorganic and followed by organic. Today, trend is reversed. But physical chemistry, without physical chemistry knowledge, you can't develop anything. And chemical engineering is necessary based on the physical chemistry based aspects. Unless and until your physical chemistry is strong, you cannot communicate with the chemical engineers. So in ICT, our syllabus major emphasis is on the physical chemistry based subjects. Very, very important branch. And good physical chemist today is not available in the market. So if you want to have good job and if you have sound knowledge of physical chemistry, again, there is in academics also we'll find lots of scope for the physical chemist. Chemical engineering, I will not talk, sir is going to talk. And anyway, it's basically, as a chemist, you should have good communication skills with the chemical engineer. What way they think, what type of data they require. That is very, very important for chemists. While performing the experiment, you should first communicate with the chemical engineers and then begin your experiments. Then scale-ups and all other studies will be really easy. So chemical engineering is another very, very important branch, and without that, you can't do this. Now, chemistry knowledge, what type of skills are necessary when you want to do the chemistry? First, you should understand the principles underlying different phenomena, connect chemistry with daily life. You should have good collecting, record keeping, interpreting, storing, and retrieving the analyzing and interpreting data. All these skills are necessary. Many of us are poor in record keeping. We do the experiment, next day forget, we don't know what we did. Even sequence is very, very important while doing the reaction. Otherwise, reproducibility will not be there in your analysis or data also. How you analyze record keeping is a very, very important aspect for doing the experiments. So that's why I said collecting, record keeping. Many of us are forgetting about these skills. We think what is there? I am just written the. Even if you change the sequence, your yields and everything will be different. And your results will not be reproducible. So keeping data is very, very important. Ability to analyze the problem, identify the tools required for this problem is very important. Suppose we are doing the reaction. First hand, you should know how you are going to analyze it. You should not start the reaction without knowing how you will analyze that. So all this planning is very, very important while doing the experiment. Communication is again important. Many of us are doing the reaction but not able to communicate what we did. And sometimes communication skills are really important and it plays a significant role in industry, particularly if you cannot able to communicate, you can't survive in the industry. So try to develop your communication skills. Then decision making. You are doing the experiment, failing, again failing, again failing. At some stage you make a decision, how long I can do this? Or I should find some another pathway. So that decision-making ability is very important that you should develop during the experimentation part. So career opportunities, what type of career opportunities are there in production, in R&D, analysis, in all these field PhDs are required. Don't say that what is the role of a PhD person in the production. No, it has a significant role there. Public work departments, military, MTR brand foods, they are basically developed for military under harsh condition, how our soldiers will get the food. So chemistry-based knowledge was useful to develop the food for the military under harsh conditions. Again, food chemistry is important. Industrial R&D, production department, teaching field is also important. Central and state government departments, BRC, DRDO, ISRO, Drug Administration. You can also prepare for UPSC, MPSC examination or research institute, IT industry. By the way, there is a new branch emerging. Those who are good in the computer programming and those who are having the good knowledge of chemistry. Chem informatics is a branch which is coming up. And there are many job opportunities in chem informatics, chemoinformatics, whatever you say. So using the chemistry data and interpreting something. For example, with today ChemDraw, you can analyze the NMR, right? Or you can, based on the structure, you can draw its chemical name. How this has happened? Because of the knowledge of chemistry and IT. So all these such type of softwares are required for chemists, and unless and until chemist plays a significant role in development of such software, IT industry and chem IT industry will not grow. So there is a manpower requirement for chem IT. Journalism, science journalism is literally missing in this country. You don't find good journalists who can communicate the science knowledge to the common public. Lots of research is going on, but it is not reaching to the masses. Unless and until manpower is there, we will communicate all this journalism to the masses. Again, there is a vacancies here. Lots of job opportunities are there. If you have good writing ability skills, and if you can communicate complex science into the simple science, this field is for you. Marketing and sales is another area. There are employment in tertiary sectors like event management, tourism, self-employment, consultant. You can also start your own startups based on your concepts. Communication skills, as I mentioned to you, then writing skills are also equally important. You may have very good research, but you have not written your paper properly, it will not go into the good quality journal. First draft itself plays a significant role while you have written your manuscript. So writing skills are very, very important. If you don't have, join the English classes and improve your writing skills. Without that, you cannot grow. Then speaking and listening ability is also important. How to behave in the masses. Companies judge students based on how you listen, how good you are listener. So all these skills are very, very important. Communication skill, quite often PhD students say that they are not so important. It's not like that. Without that, you can't survive. As I mentioned to you, writing skill, many of you, I have seen, we have the course called research methodology. Many students are not able to write a simple letter addressed to some seniors. So therefore, effective personal and business letters writing, try to understand that, how to write. You may be already writing the letters to the science journal editors. You see that how effective you are writing there, how effectively you are communicating, what is there in your manuscript. That makes a significant impact. Report writing. Research paper writing and report writing, these are different aspects. In industry, most of the things are going in a report writing format. What you have done and how you have done. Proposal writing. To get a grant, proposal writing is another skill. Keeping records, articles, reviews, patent. All these writings are different ways of writing. You should know. Speaking, how you communicate on the telephone, meeting with customers and suppliers, and presentations. Listening skills, we may feel this is a passive, but it's not like that. People are observing. So it's how you are focusing your attention about person who is speaking. So these are again important. E-communication. Again, ignore parameter while developing your career. How you write your email. Your email should be effective. How to write your email, you will find tons of articles on the Google as well as in the YouTube. Please see that you are writing effective e-communication. Electronic mail, video conferencing, displays. Then next advice to all of you that you should do personal SWOT analysis. What is this SWOT analysis? You understand your strengths. Positive, it can be internal. You understand your weaknesses also. What are the negative points in your personality? You try to understand. If you don't know, ask your friends, what are my weaknesses? Probably we are not aware about the weaknesses present in us. So try to understand and do the SWOT analysis. Then what type of opportunities for a person like me is there? Try to understand that. Accordingly, develop your career. and try to understand what is a threat. Suppose I develop career in specific field, whether that field will survive longer or some threats are there. Threat analysis is also important. That's why one should do SWOT analysis about himself. And SWOT matrix you can do like this. You try to write your strength, weakness, opportunities, threat, helpful, harmful, internal, external. If you fill this matrix, you will understand yourself. So try to understand yourself before deciding where you want to develop your career. Okay. So this is all about the SWOT analysis. Now, chemical industry as such, my advice to all of you is that since you are doing advanced research, please do at least one postdoctoral fellowship abroad somewhere. Why this is important? Because you will come across with the advanced techniques. You will understand the different culture, how people work in different culture, that transform you significantly. And then you come back and do career in India. That is very, very important. So at least do at least one postdoc and then come back and do career wherever you want. It can be in academics, it can be in research institution, wherever you go. Indian chemical industry is growing. It will definitely grow, and there is a lots of requirement of manpower. So it will not happen that you will not get a job. You will get a bright jobs, good jobs, and try to develop all these employability skills within you. As I mentioned, most of them are summarized here. These are some leading manufacturers. There are plenty as such. This one. I will include DST, yes. These are some representative I had taken initially. I will include more. Many research institutions are awaiting. Companies? Okay. So Atul, BASF, Reliance, Excel, Galaxy, GSCL, Ardelia, Jubilant, Monsanto, Nosil, PI, RCF, Sudarshan, Tata Chemicals, many. All big groups have their own chemical companies. They have R&Ds. All of them have R&Ds, and most of them are located in Mumbai. Most of them are located in Mumbai. Those who have interest in pharmaceutical industry, you will find most of the pharmaceutical industry based companies are in Hyderabad. And most of the pharmaceutical based production units are in Himachal Pradesh due to the tax benefits. Such typical distribution you can observe all over India. And many industries are located in Gujarat, Vapi, in that region, Surat, Gujarat, Vapi. But many of them were small scale as well as large scale also. Many institutes needs good faculties. So if you develop good research career, you can apply and get the faculty positions in all these institutions. For that, you need to develop good research career, publish in good quality journal level papers. And not only doing the research, you should know what you are doing and why you are doing and where it is applied. Don't do just research for sake of research. You should know where it will be used. Those who have interest in just chemistry, not you have already done your master's, but you want to know something more about chemistry, there are many online courses. You can go to the Swayam portal also, NPTEL portal also. Suppose you missed out something to learn, you can register yourself and do that particular course and learn more knowledge on the given topic. Today, this opportunity is there, and all these courses are taught just like a classroom. Probably in your PhD coursework, you might have done some online courses with NPTEL and SWAYAM. There are plenty of courses available. And my recommendation is go to NPTEL. NPTEL is the best site in which you will get the subjects, whatever you want, and you can learn all those things in these online courses. There are many important institutes all over India wherein you can develop your careers, IITs, ICTs, BARC, DRDO, many more. Then some of you already have been admitted to PhD program, but if you are not qualified GATE or NET, please try to appear it again and qualify the NET and GATE. If you are not, it is very important milestone in your career. You should qualify NET and GATE. You may not use it as a lecturership or something, but it is important that you have qualified the NET. It is important addition to your CV. So you should do that. There are many opportunities abroad also. And that's why I said after PhD, please do at least one postdoc. As I told you, there are many emerging fields are there in the chemical sector, chem informatics. If you have interest in IT as well as chemistry, please develop this field. There are many institutions which are offering the diploma and graduate courses in this particular field. And these are listed here. Even abroad, there are many institutions which are offering chem informatics based courses. So as far as careers in chemistry, you can see lots of scope. And as you grow with your career, you can get more interest into other areas also and try to learn what you are doing and why you are doing. Any instrument, don't use it just like a black box. Try to understand the fundamentals. Okay. So with this, I would like to thank for your kind attention. And if you have any queries, feel free to communicate.
Yeah, if you are interested, any quick questions, please you can interact with Professor Banage.
I given 30 minutes, so I finished within my time. I have hopes. Yes. PhD, again, I'm telling you, you are doing in all advanced areas, you are already doing the research. And these areas has tremendous potential. What you should learn, how to do the research, how to analyze the problem, how to tackle the problem, how to solve the problem. And with during that, you acquire all these skills and develop yourself as a full personality so that you can get a good jobs.
Yes, please. Keep close.
Yeah. Hello. Yeah. Thank you very much, sir. Very informative, at least for people who are not from chemistry. At least got to know what. I wanted to ask you, what is this? Right. Industries catch up those.
Yes, yes.
No. Everything they make industry. Similarly, what are the other interdisciplinary?
Nanotechnology. Nanotechnology is an interdisciplinary subject. It goes from chemistry, biology, physics, everywhere nanotechnology is required. Nanomaterials. Material science as such, you will find lots of scope because developing new material is required. It's an interdisciplinary field. Then next important point, which sir will talk, scaling up. You are doing at some scale, which is at the lab scale. Real challenges from lab scale to commercial scale. And that is very, very important. And one should know the economics of the reaction which you are doing. You should not produce from high value product to low value product just for sake of the reaction. Unless and until you are doing some fundamental studies around that. Yes.
The mic closer.
Artificial intelligence. Yes. AI is already playing a significant role in all sectors of the chemistry, particularly synthetic organic chemistry. Today, you give the molecule and AI can predict what way you can synthesize it. But today, AI will give you 5-6 route. Finally, you need to use your intelligence to select proper route. AI is still developing. It's not developed. But AI will play significant role. Again, I'm telling you, be computer savvy. You should know the computer programming. You should know what is happening around you. Don't just focus on what you are doing. You should know what is going around you. One more point I missed is industrial challenges. When you go to research labs, doing fresh PhD and go to industry, what industry expect? That is very, very important. Industry is looking for all improvements in the yields, developing new technologies. Even if you improve their yield by 5%, 1%, in terms of money, it is a significant amount. They value that. As a chemist, you may feel that 90% yield is okay. Industry is not happy with that. If you can take it to 95, at 5% translates into large money to that industry. I will give you one example, simple example. In Monsanto process, chemist added just 5 ml of 5% of the water to that. Yields were improved, kinetics was improved, 20 to 40% reaction was faster. Same plant now produces 3 to 4 times larger quantity of the product. Right? Innovation wise, chemists may feel that it is a simple thing, but no, for industry, it is a very different thing. Yes.
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 Uh, there was one slide where you mentioned about entrepreneur. A lot of the market share has dominancy from especially in the chemical science. Something is bad.
It plays, yes. All global factor plays a significant role on the domestic production. I can give you one classic example. Acetic acid production in 80s used to done by the ethanol oxidation. Globally, carbonylation process dominated, all these plants were shut down. So global parameters, today this is starting material, tomorrow your product may be the starting material. We don't know that.
My question is that based on your experience, and the same question will also go to.
Yeah, do ask me.
That let's say I'm doing something over here. I'm doing the other countries are, let's say, 1 or 2 steps ahead of me. But there is so much potential over here that I can start it and make it big. Entrepreneurship. How to, I mean, what are the factors that as a layman, first generation, as per your experience, what are the factors that the person should have to start it and to make it big?
I will answer it.
Sir will answer this question. It is very tricky because your product should be first of all market acceptable. If it is market acceptable, you should have capability to scale it up quickly and put it into the market before other players entered into the market. That is very important. Another point, as far as if those who want to do their own production units or something, you should have good knowledge of finances. Many of us don't know how to read the balance sheets of the company. What are those terms in the balance sheet? So you should be aware about chemical project economics as well as reading the balance sheet, different terms, finance related terms, you should be aware. What is equity? What is all these things? What is debt? Everything you should.
Professor Banagi, I will just ask one comment and maybe a query. See, if you look at for chemists today, the student who is just completing PhD, see, I have also guided a large number of students, HVNA students. I know that the fourth year or fifth year, they become tense because there are first opportunity, everybody tries for postdoctoral research, PDF opportunity. Suppose your field is very attractive and somebody is automatically calling you by seeing your publication in the third year or fourth year, you are lucky to get it. Or your guide is more, internationally recognized networking person. He has a lot of contacts. He has been in abroad for many years, many places. So he helps to get sending your biodata
Yes, it is correct.
PDF. Okay. So PDF is the first opportunity everybody try to get. Otherwise, on the fifth year, they become very nervous because what to do next? Because it's not that job is chemistry, for a chemistry person, job is just available in the open. You say that lecturership, not that easy. Press PhD is never called for any IIT or any IISc, nowhere they will take you. And if you want to go to some industry, there are very limited industries. This is where I thought we may focus. Those industries, they have their R&D, in-house R&D, and they are looking for maybe Reliance, BASF. There are many companies looking for eMerck. So many are trying to look for
Evonik
some
is there.
young PhD scholars. They want to then nurture them into their product or in the such jobs. Where are those opportunities? What is the kind of pay they get compared to, in general, and all those. Otherwise, the teaching in private institution and going for some job that is not as per your PhD requirement. Oh, these are all not something that finally you are forced to do, and look for some PDF, look for some job in industry. The most important thing that I feel today, the way you have shown $30 billion business is there in chemistry. Today, the entire country is depending on Chinese import, the raw materials, many ingredients. If you take API, everything comes from China.
Everything
And
comes from
government of
China.
India has made a new chemical policy by which industries are trying to attract young research scholars, PhD scholars. They want to start some new, as you mentioned, some new technology, new product, doing it in an innovative way. So probably that I was thinking that those things also will emerge during this lecture. So that only will help. Otherwise, no. I will tell you, a fifth year student will look for maybe PDF, or the person looks for a job. After doing MSc, somebody has done MPhil also or not. Another 5 years for PhD. Where is the job opportunity for chemistry?
Sir, what we observed that jobs are there. Students are not able to face the interviews in a way company expectations are different.
No,
They
that's that means that there is a gap between the
Yes.
potential research scholars and the industry requirement. That is what I wanted. Probably Professor Joshi may address it. Then third point, you have PDF and job. Third is entrepreneurship. And many potential scholars today, they are thinking that why not? Why I cannot take risk? Why I should not start something on my own? Why I am looking for every time somebody will give me a job and apply and so on. So that motivation also required for entrepreneurship. In fact, we are going to introduce one elective on entrepreneurship.
In fact, incubation center can help. Suppose you develop some incubation center here.
We have in BRC,
And
we have
if-
in other
if-
institutes.
If they communicate with the industry and try to develop their concepts into commercial level, incubation center can play a significant role there. To find out finances, to find out the location, to start new industry, incubation center can play a role there.
No, there are potential funding people. See, first thing that if I want to start some startup, I need somebody who will fund it. They go to bank, they will ask, what is your experience? So many questions are coming. What
Yes,
is your
they
end
are,
product?
they are.
What is the marketing? So, but there are many private, many industrial, many, institutional fundings are available. That kind of funding will help the student to go bold into this entrepreneurship. So he is very much
I
interested.
can, sir, name few companies because I come across with many companies who are promoting the startups. For example, RT industry has started attracting the young people and starting their own entrepreneurship cell in their own company. There are many companies like this. They have thinking about same line and they are calling youngsters to do some startup with them.
I think today we have to motivate our youngsters into their entrepreneurship. Okay. It's
That's
not
the
like
scope.
not like those days that I can only join some big company and then get a monthly salary. You should motivate
Sir,
them to be
I can
owners.
see that all of them are working on nanomaterial. Nanomaterial commercialization is a part which they can think of.
That is the best
That's
topic
not,
for.
that's not available in the market. Nanomaterials, if they are come up with some companies, they can do the
I think
marketing.
you will also, Dasgupta will also accept. I think China makes the cheapest and biggest volume of all this nanotube, nanomaterial, everything. And we
But in
simply buy.
India, no, India, you try to purchase it, not so easy. There is a need, there is a market for nanomaterials in India. Not available so easily. Even pharmaceutical sector needs different metal oxide like zinc oxide, magnesium oxide in nanoforms. Simple metal oxides. Again, suppliers are not there. So there is a gap, there is a demand, but we have to find out, identify the products, and we can develop
No,
technology.
in fact, I want to motivate my young scholars
Yes.
on that only, that they are all potential scholars,
And
they are working in a place like BRC. They have the best
no,
laboratory,
all of
best
them are
guide.
working in excellent areas. I must say that their areas are really advanced areas. And they have lots of commercial potential for all of their products, whatever the topics they are working.
Yeah, thank you. But probably I'll call you once again later. That please focus on the entrepreneurship, which are the chemistry related supporting funding people for an entrepreneurship, or kind of some companies, industries. You show a list of industries where chemistry R&D is pursued, and they have in-house R&D where their job opportunity is there. So probably that they can look for such opportunities.
And many companies comes to us for the recruitment. Many students are getting job also. Those who are not getting jobs, they are not able to defend their interviews. So if you develop their skills to defend the interviews, probably they will get the jobs. That is another area which is a weak area. We are not focusing on how to face the interviews.
Any more questions from the scholars? If not, we will be having just 10 minutes break. You have tea and snacks and then come back. Unfortunately, the third speaker is not able to join due to some difficulty. He is in USA. So we will have the next lecture by Professor Joshi. He will focus more on how chemistry can be adapted into engineering, chemical engineering, and how chemical engineering scholars can go for the employment opportunity by entrepreneurship or by joining some leading chemical industries. So that will be the next talk. So I request all of you, you can have the snacks and tea and come back. I want to thank Professor Banage for an excellent overview.
My email ID is there. Whenever you feel, you communicate through email or come to ICT. I'm available. Whatever queries you have, you can definitely communicate. Presentation I'm sharing with you. Those who
Yeah,
have
we will
interest,
put it in anyway. We normally put in our YouTube.
so you can put it there.
Thank you so much.
Thank you, sir.
So let us have a break for 10 minutes and we'll come back again.
This can give me
Honorable Vice Chancellor, Dr. Kamachi Mudli, Honorable Associate Dean, Dr. Maiti, my colleague in ICT, Professor Bhange, my erstwhile colleague, Dr. Kinshuk Dasgupta, and my dear student friends. I'm very happy to be here and associate and share my experience with you. Normally, I have a habit of concluding the lecture at the beginning, then start the lecture. If you see mission statement of any university, including HBNI, it has two parts. One is, we shall develop new knowledge. And second part is for the benefit of society. And society includes society as well as industry. What are the major problems of our society? The first problem is, as far as chemical industry is concerned, whatever is overall worldwide market, India is producing only 1.4%. So this can tell you how much is the scope. For natural type of products, including natural medicines, there is a scope of 1,60,000 crores worldwide market. But though it is science generated by India, we participate 1%, even less than chemical industry. Electronics, 0.1 industry, 5.1%. Mechanical engineering, 1.5%. So in every sector, it is 1%. Right? I said that I'm going to conclude at the beginning. As far as agriculture is concerned, in the case of all the products, let it be rice, wheat, tomato, potato. Rice, wheat, we are producing 3 times less, at least 3 times less is whatever proven in the world. Tomatoes, 50 times less. And so many products. So the source of income of any nation is one is industry, where we are participating 1.5%. Agriculture, where we are producing 1/3. And third is service industry. Service industry looks attractive, but the quality of job, it's service to the world. Nothing original. We don't produce any software which is sold worldwide and earns a lot of money for India. We do some, in simple language, some additions, subtractions, develop software for that, and get salary as 50,000 rupees. Soon you burn out. So the most important point I'm communicating is, there is a huge scope. The total money that we get from these 3 sources is 70%, and remaining 30% all put together is 200,000 crores. 200,000 crores. If we divide by our population 140 crores, it means that the per capita income is 2 lakh rupees, or about maybe $1,200, $1,500 per person. The point I'm trying to communicate is, per person 2 lakh rupees, we are in the world 142nd from the top. 142nd. that $2,000 or I'm sorry, 2 lakh rupees per year per person, and we are 10th from the bottom. And what is the reason? Our industry is doing only 1%. Our agriculture is not doing very well. And all these opportunities are there with our young community. I'll tell you many examples. First of all, if we ask industry why this is so, why we are participating only 1% in the world, what is the reason? The first reason that they say is cost of energy in India is high. Per unit, pay 10 rupees here in India, in United States 5 rupees, in Switzerland 3 rupees, and in Middle East it is 0. Second is cost of finance is high. Our interest rate is 12%. In US it is 5%. In Switzerland it is 3%. In Middle East there is no interest. So under these conditions, how can we compete in the world? If we want money, we need to get at 12%. Their final complaint is we don't get anything meaningful from educational and research institutions. If we ask academics like us, why this is the condition, why our nation is poor, why our per capita income is 2 lakh rupees, we have our own set of complaints. We don't get good salary. Our counterparts, our classmates in industry, they get 3 times. These days, we don't get good PhD students. At our time, 30, 40 years ago, we were getting good students, means we were good. And you students are not good. If we say that these days we don't get good students, students have a right to say that these days teachers are not good. What I'm trying to say is there is a certain observation that we are not doing internationally good and our nation is poor and we want to solve this problem. And every sector of the society, I have made a list of problems and the complaints made by different sectors of the society. So complaints after complaints after complaints, and give some reasons why I'm not doing the job. When I'm teaching, I write 7 excuses in my notebook and give homework to the students. And when it is not done, half done, they give some excuse. I tell him that this is 7th excuse, which is already there. So if you want to be successful in life, the first and foremost important thing is never complain in life. Never have excuses in life. Those who have complaints, normally I say in terms of efficiency, those who have few complaints, then they are having a problem of cold. If anybody has plenty complaints right from the morning, share prices have gone down today, too much of rains, I wanted something, but stores is taking so much time. So the one who has plenty complaints, then that fellow is suffering from cancer and he is never going to be successful. So I will repeat this again and again. For research and for becoming successful, normally we feel that there has to be excellent laboratory for developing processes, good analytical facilities, good library, good internet, good scientists, good students. From my experience of 52 years, active experience, I'll tell you none of these are important, none. What is important is whether you can concentrate your mind on any problem. And only those can concentrate, those who have no complaint in life. They are happy within, all the time smiling. Right? The world is so beautiful. Lakes are beautiful, oceans are beautiful, jungles are beautiful. Girls are, as well as boys are, beautiful and handsome respectively. Look at them like that. And if you develop this habit of no complaint and remaining pleased all the time and happy all the time, then money is useful, library is useful, internet is useful, but it is not mandatory. But if you keep on complaining in life and if you are not happy person, resourceful person, where you can get new ideas come to a mind where the person is not having any problems in the mind. Normally what people do after graduation, look for the job. After getting the job, then I want wife, I want husband. Then after that, I want house. Then after house, I want one car. Then I want second car. Then I want to have shares, some investment. Followed that, some second house somewhere. And you retire. You get excellent function for your retirement and people talk about nice about you. But what is that you have done in life? Complaints after complaints. Because when you have a house, that project is not simple. Okay? It's to be done. It's not to be done. But what is your main job? Main job is our country is poor and has only 1% business. Why our agriculture or our land has become unfertile? Is there any chemistry of soils by which we can have 2 recommendations, 3 recommendations? My experience is any person can contribute 5 innovations in life, right? But right now, the number is so poor that we are poor. Now, how many scientists are required? If there are 10,000 scientists, there are 1,000 scientists only in atomic energy or more. CSIR has 16,000 scientists. We need 10,000 scientists who are making 5 innovations in their lifetime. All the problems of our nation will get solved. What is required? Concentration of mind, which is very, I think, most important, and not to worry about. The rainy season will come, no, without asking us. And there will be big rains on one. You will have some problem in walking. There will be water logging. What is to be complained about? So this habit, my dear friends, giving excuses to whatever we are not able to do nice retrospection every Saturday. What I tell my students, point number 1 is every 20 minutes, write in your diary what exactly you have done. Have you really thought about something new? Or it is lost, time is lost. Unfructified manner, the time is lost. Per month and last Saturday of the month, do honest introspection. What has happened? When this survey was done by India, for India, by a good agency, please note and try to listen. It is 3%. Why India is poor? It is complaining. It is not concentrating mind. no innovations, and losing time day after day, year after year. You do it yourself. Don't show it to anybody. But for a diary, if you want, I'm ready to give any number of diaries so that you can write. If you want 16,000 diaries for atomic energy, I'm ready to give 16,000. But do this honest job. Where the time goes, I told you many times, think about past things where we might have made error. And then I should not have made that error. Otherwise, I would have been better today. A lot of time goes in that. And there is always an anxiety about future. Will I get husband? I'll tell you with confidence, all boys get wives and all girls get. But there is a time loss in the process. After that child, after that, one after the another, we have a series of incidences in life where we want to worry. That can never be, you cannot be entrepreneur, you cannot be good scientist. You will get job, no problem. But after getting the job, are you solving the basic problem of university, basic problem of the nation? Are you contributing to the nation? I tell you, I have 50 examples to tell you how the innovation was done and how it is simple and straightforward. Every year, I take my PhD students for picnic. And about 4 years ago, lot of all the students, 20 of them, they came to me, and, sir, we have not arranged picnic this year. And that was the truth. I said, where should we go? So they told me that wherever there are waterfalls and excellent nature, we should go there. So our own coastal area is famous for falls. And we selected the bottommost district of Maharashtra, that is Sindhudurga, for picnic. Picnic doesn't need a lot of money. I can myself fund. But by that, I appoint 2 students for managing all the picnic, and they learn lot of things. I tell them to go first to Sindhudurg, wherever you are going to stay. Let us find out whether that place is clean and wherever we want to go. And they learn good things. The story goes further. We went in Sindhudurg district and we were walking just in the nature. And what they saw, there are plenty cashew fruits, cashew trees. And cashew fruits were there, but cashew fruits had fallen and had formed a big layer. The students asked me, there are these many cashew fruits, why we are not doing something? I told them, you wanted picnic. I never wanted picnic. So you have come with me. You have seen this problem. I have not told this problem to you. So you have to find the solution. They went to revenue department of that district and found out that in the district, 21 lakh tons of fruits are being wasted every year. 21 lakh tons. There is one process in Goa for making feni. Has anybody tested feni? Are you from Goa? Yeah. So if we make feni out of 21 lakh tons of fruits, every person will have to drink 1 liter of penny every day. That much quantity is there. You must have consumed 200 ml maximum. Yeah, 200 ml. So 1 liter, but every day, 1 liter. So that is a resource. So what is to be done further? They went through internet and found that the cashew nut apples has vitamin B, vitamin C, has dietary fibers, and it has so many valuable biochemicals. Then, as per the individual strength of students, I told them to find out ways to isolate vitamin B, etc., all the components, and they came out with certain report. And they also saw what is the worldwide market. And they found that only Sindhudurga district, by processing 20 lakh tons, can generate 40,000 crores for that district. That's what they found out. Now, this is to be implemented in some form, and preferably entrepreneurship. Preferably entrepreneurship. So they said that, sir, can we solve this problem? Because perhaps they have in mind that they will become entrepreneurs themselves, and 40,000 crores is a big money. And 40,000 crores is expected to make the local income of the people 3 times, and we jump to the number 30 in the worldwide instead of 140. I said, solve the problem. It is your problem. No? So they found the methods. First one is solid liquid extraction. The fruits are perishable, therefore drying is required. Drying is a unit operation which is not yet mature. A lot of chemical engineering is required. Defining internal diffusion, perhaps internal evaporation, external diffusion, and then the flow pattern in the dryer. I'll tell you a little bit, I'm deviating, but I'll definitely come back to the story. By drying grapes, we get resins. How to get problems, and there are good thing about India is we are number 1 in terms of problems faced by us. You go anywhere, you'll make a big list of problems. There won't be any. So Corona started, and these grape growing people came to me, said that all the food markets have stopped. We are unable to market our grapes and we will be in loss. So if you can do some innovation in the drying process, in the resin making process, it will help us. If the same machine makes it 2 times, then we will process all the grapes. So it was chemical engineering problem. So driving force is the partial pressure in air and equilibrium vapor pressure of water. And there will be certain mass transfers, all mass transfers, internal mass transfer, external mass transfer, evaporation, etc. The students did detailed modeling of, did the experiments. First of all, they took only 20 grapes for laboratory. After they understood the diffusion phenomena on 20 grapes, they went to 2 kilos. Then they went to 20 kilos. Then they went to 200 kilos. Anyway, I was expert to scale up right from 20 grapes to whatever is required. But increasing my personal confidence That was not the objective. Objective was to prepare new generation who becomes capable themselves. So after 200 kgs, somehow they felt that we can do. So the next batch was 50 tons. 50 tons. And they proved that instead of 16 days, we need 8 days. So whenever any air flows inside, whether it distributes uniformly or non-uniformly, and whether every grape can get a good atmosphere for drying, that was the mathematical problem, which they solved by computational fluid dynamics. On the dryer as a whole, and for a single grape in particular. This got implemented and problem got solved. Lot of money, lot of money, lot of money. Coming back to the original story, first step, the cashew fruits are perishable. Within a couple of days, they get deteriorated. But after drying and making powder, it lasts for 2 years. Right? And the second reason was cashew fruits are available only for 100 days. And if we make, design, and implement any plant which operates for 100 days only, that can never be economical. It has to be run throughout the year. So first step is drying, making powder and storing it and extracting those valuable components and running the factory throughout the year. That was economical. The students, boys and girls, this right from powder, fruit powder, they did extraction process. They found solvent. Right now, there was a discussion for finding the optimum solvent. There was a need for molecular modeling. So if I'm having 20 students, all the 20 students need not do molecular modeling. One of them can do molecular modeling of whatever is required. I'm going to describe to you a few more examples, but this I'll take further. District is 80 kilometers by 80 kilometers. And we realized that bringing cashew apples, cashew fruits from location to location demands money. So therefore we decided that we will have 80 distributed plants and each plant handling 25,000 tons of cashew apples per year. What was going to be the result of one 20,000 jobs? Each one getting at least 20,000, some getting 40, 50,000 managers, 1 lakh rupees, some getting 15,000, 10,000. I already told you per capita income increased 3 times. So for one plant of 25,000 tons, the capital cost required was 60 crores. And the local minister, local in charge of that district, he contacted me. He heard from somewhere that the local wealth is going to increase. He asked me to write 1 page about where is the beginning and what is going to be the benefit for my district. I wrote 1 page and showed a lot of money at the end of that. He straight away put it in the ministerial committee and all the ministers approved within few seconds. The government was, and they quickly made in the budget of next year, 60 crores of rupees. Their only requirement was let local people, local farmers contribute 10%, 90% government gives. I thought this was fair because the farmer should also feel ownership for the entire activity, right from collecting cashew apples to the marketing of products. By the way, marketing was done by the students, and there is enough market, more than enough international market. So I went to Sindhudurga. Now the objective was 6 crores. Summary is, there are problems in the society. Don't complain in life. Don't have excuses. The problems will come. Now, if 6 crores are to be collected, and if I cry that how can I collect 6 crores from the farmers? About 15,000 farmers, how can I collect it? Each one should give 10,000 rupees. If I cry, then I would have lost there. And nurturing the students, giving them the confidence and guiding them and approving the correct procedure for extraction and for drying and for, you heard in the morning, chromatographic separation. So when you extract valuables, what we get in solvent, ethanol, say ethanol solvent, you get vitamin B, vitamin C, you get various other components. And they were analyzing by HPLC. Right? And HPLC was giving nice 4-5 peaks. So whether preparative chromatography for 25,000 tons of cashew apples, whether that can be developed, okay, is a problem. A problem. But it has to be solved. The students have solved that problem. Preparative chromatography on that scale. So when I went there, I requested the farmers to get together and let us see how we can solve the problem. I also invited vice chairman of the local bank. He came. 6 crores, 6,000 farmers, 10,000 rupees per farmer. After some discussion, the vice chairman declared, I will give a loan of 10,000 rupees to each of you, and you pay back. Anyway, the project looks very profitable. You pay me back to the bank in 5 years. It is negligible money, and 6 crores were collected. We went back to the government and said that our 6 crores are ready. Went back to the government. Government took very wise stand. Professor Joshi is approaching us for giving 54 crores. Let us examine what is that he's saying. I thought this is most reasonable. Let it find. And they gave it to, there is an expert committee in Vasantdada Sugar Institute near Pune. They examined. I know how to do industrial calculations myself. So it was approved. Then I decided, if I tell this activity to any businessman, he will invest 60 crores on his own and earn 2,000 crores. Okay? So lot of machinery is required. Lot of fruit dryers are required. For 25,000 tons, 500 dryers are required. And each dryer is going to generate money. So there can be local entrepreneurs for drying, local entrepreneurs for fabrication of dryer, fabrication of extractor, fabrication of chromatographic separation, and lot of things, packaging, and safety, and many things. So whether entrepreneurs can be generated for this. First of all, these students who had come for picnic, they were already ready for becoming entrepreneurs for this activity. Anyway, whenever there is a money attraction, then let there be businessmen or entrepreneurs. Or I have another 5 stories like this. And if time is useful, plenty time is there. I have 50 stories like this. The summary is how many opportunities are there. Next year, this coming June, there is a conference in New York of Marathi speaking people. And 5,000 of them are coming. And I'm invited as a chief guest. And I'm also told what is the subject to be talked about. And the subject is, there are 28 districts in Maharashtra. You list the opportunities in each district and tell us something preliminary at least, how to make all those opportunities successful. That is the lecture I'm giving. So I'm giving you of Sindhudurga only cashew fruits. If you see that entire area, how many things are there? Plenty things are there. But anyway, so opportunities come, they are not never clearly listed in internet. We have to move around. We have to talk to the people, right? Talk to the people. While doing PhD also, why you should go to industry? Somebody told me that they show you one plant and that's it. Remaining 6 months, you go have a good breakfast, good lunch, good snacks and come back. And those 6 months are boring. I was there in NoSil in 1970. On my own, I went to water treatment plant. And that is basically ion exchange. Cations are removed and then anions are removed and water is made soft without. And for generation and regeneration, they were using chemicals. I measured the concentrations and quantities and showed them that they can save 10 lakh rupees by controlling the quantities, not leaving it to the operators, but do something. And 10 lakh rupees, I could have started such units are there in 1,000 places in India. Every industry has water softener that can become entrepreneurship. So there is, if you want something, somebody is going to give a problem, or here is a problem and you are going to become billionaire in 10 years, this is never going to happen. This is never going to happen. You will have to keep your eyes wide open. And this you don't forget. No complaints. No complaints. Smiling all the time. Then only you will get good answers. Or whatever answers are given, you will be able to make good meaning out of it. Otherwise, you will interact with many people and nothing will come out at the end. Okay? One more example. Maybe two more. What is the time? 8 o'clock? 7:30. Otherwise, I can go, what is the bridge between chemistry and chemical engineering and what are the qualities which are required. And for entrepreneurship, you really join such courses. As ICT, we have started social entrepreneurship as a course where we will teach all the subjects other than chemical engineering. And they will. I'll tell you one more example. Ethanol to acetic acid, Professor Bhange told you, is done by air oxidation using copper cloth as a catalyst. And the hydrogen is abstracted and is removed as water. And then that acetaldehyde is further oxidized to give acetic acid. Then acetic acid plus ethanol, you get ester ethyl acetate and you get water as a product. 3 million tons per year is the Indian market. So one of my students, he said that anyway from one alcohol, acetic acid is made, and another alcohol is attached to make ethyl acetate. So why not make in single step from 2 ethanol molecules, 1 ethyl acetate? And we will get valuable hydrogen. It will not be oxidized to water. This was PhD problem. After while completing the PhD, he got the solution. That is, he found the catalyst, which is not deactivated and deactivated after 1 year. I'm expert in reactor design. So there is a move by central government for hydrogen, biohydrogen, bioethanol, bioelectricity. There is a big move. So we also participated with this idea and it got approved. If basic idea is good, if really making money, it gets approved. And we got about 15 crores of rupees as capital for capital grant. Overall requirement was 50 crores. Again, same problem. So we were looking for investors that who can implement, and 40 tons per day was going to be a pilot plant. So while we were talking to various people, one bank said that, why you are talking to investors? We will give you 25 crores. Your business looks so attractive, you will pay us within 2 years. He said yes. And that message spread throughout the world. That bank is giving us. We have yet to put the plant 40 tons per day. It will be put. I'll do the scale up myself. Next numbers, I will not tell. But you cannot imagine that entrepreneur can become one of the richest person in India. Ethyl acetate, I have 50 examples. 50. But what is the pre-requirement? I said, I'm going to repeat. Don't complain. Be happy within, be smiling within, and keep track of your time all the time. Are you wasting your time? Then you will be successful. Now, a few minutes on interface. I have been consultant to, I'm the maximum utilized consultant in India amongst all the engineers, and now having 55 years of experience. Okay. So any process, I have confidence because of so many things have happened. Some were giving problems, sometimes solution was found, and then it went further. So what I recommend all the time, whenever we are developing process in the laboratory, keep track of money. How much raw material, how much power is required for stirrer, how much power is required for heating, how much power is required for cooling, and how much quantity we are spending for utilities, for raw material. What is total cost of production? Keep this all the time in mind. You should not get surprised at the end of PhD or at the end of the analysis that this was not profitable activity at all. And all the time, I tell my students at ICT, many people come out with ideas. Right? Listen to those ideas carefully. And in the mind, do mind calculations. How much profit at the end it is going to give. If that is giving profit, this is going on in your mind, then praise that person eminently, praise that person. And in our mind, it says that it is not profitable, then give a nice smile to that person. But this should become as a habit. Unless you have a habit of money calculations, you don't need money. You don't need it. This is a philosophical sentence. So chemical engineer and chemist, they should always work together while developing process. And there are various steps in any synthesis, say catalytic hydrogenation. Right? So catalytic hydrogenation, I'll tell you a little bit of story. It was being done, no catalytic hydrogenation, ion filings and hydrochloric acid. You get nascent hydrogen. If nitrobenzene is to be reduced to aniline, then put nitrobenzene also, put ion filings, put hydrochloric acid, and nitrobenzene will become aniline. Problem. Slowly, the price of ion filings and hydrochloric acid, and practically purposes, all the costs, they keep on rising. But the main problem was, for 1 kilo of product, 5 kilos of solid waste was forming. And solid waste contained 5% of aniline, amino compounds, which are carcinogenic. And treating this waste was a big problem. And therefore, catalytic hydrogenation and catalytic hydrogenators were being made, not whatever catalytic hydrogenation was being done in India. It used to take 5 days, 6 days for hydrogenation, very long time. So imagine paranitrophenol to paraminophenol for what? Paracetamol. Paracetamol for what? Crocin. So only the reactors were taking 5-6 days and it was not becoming economical. So one entrepreneur requested me, such equipment is available in Switzerland. I'm telling you opportunities. Switzerland, and asked the price of such a hydrogenator. 2-ton hydrogenator, they quoted 10 crores of rupees. 10-ton hydrogenator to 10 crores. I always do mind calculations now. I ended up in Smiley. Came back and told the entrepreneur, the businessman, that it is too high and we should not. But that entrepreneur was, the businessman was more wise. He said that let us get only drawing from them. And we have excellent facilities for fabrication in India. Let us do that. So I went back. It was January. A lot of snow was falling outside. Okay. I said that we want just drawings and we will fabricate in India. They said, most welcome. We will give you drawings. The cost of drawings is 9.9 crores. You say whatever you want in remaining 10 crores. It was cold outside, but my blood started boiling. Dear entrepreneurs, you face such difficulties yourself. And that was the starting point for 4 entrepreneurs. We made in India. I'll not tell the big story. I'll tell the science behind it. I can tell, but now this is not the occasion. But it was made in 12.5 lakh of rupees, the entire reactor. And now more than 1,000 hydrogenations in India, as well as Germany, and as well as in Switzerland, are happening with our design. How much business they are making? Individually, they are making 300 crore business fabrication. So you will come to know many ideas if you keep your eyes open. I told about chemical engineering, developing the process you get together. And in hydrogenation, the several steps are hydrogen has to dissolve in liquid. From liquid, it has to go to the catalyst surface. There is internal diffusion of hydrogen. Then hydrogen has to react with whatever is the substrate, nitrobenzene. The product will form and the product will dissolve. So out of all these steps, at various temperatures, at various pressures, at various catalyst loadings, at various concentration of nitrobenzene, what is the rate controlling step? Is it dissolution of hydrogen? Is it the chemical reaction? Is it the internal diffusion? So we should help the lab person for finding such rate controlling step. Only developing the process is not enough for scale-up. And after finding the rate controlling step, finding the kinetics of that particular step, that will complete. So in any given reactor, for partial pressure, for temperature, for concentration, for catalyst loading, we know the performance of that particular point. And if you integrate the performance of all the points in the reactor, you'll get the total performance. Or in other words, if you know the total performance that you want to manufacture 50 tons per day, you know what is the performance required at all the points, and you should know the method of integration, that is mathematical modeling. So that is an additional ability. If you wish, in a company, there need not be all modelers, all computational fluid dynamics persons, all molecular modeling persons. And these days, what is important is environmental modeling. You know that climate change is happening, and what is that your industry is going to do, and what are the present industries that they are doing, you need to be aware of. And do that modeling also as a side exercise. There are many courses which are available. But we becoming alert that our new activity, what is that it is going to do to that atmosphere, to the environment, that is important. As far as research is concerned, typical environment, other important subject is safety. So there are safe ways of doing it. If you are using hydrogen peroxide, toothpaste is okay, some quantity you are using. You don't use the entire tube for mouthwash. That much hydrogen peroxide you don't consume. Safety is important, and pollution that you are going to, your activity is going to do, that is also important. So chemical reaction engineering, fluid mechanics, heat transfer, mass transfer, process control, and optimization. These are the subjects in chemical engineering. And everywhere, as academician, there is a huge scope for work. For instance, if we take process control, then understanding the dynamics of each equipment and measurement of performance and developing the soft sensors for that. And after getting all those data, when you go to work practice or industry, you will know that there is a control room, and in the control room, all these variables, they are recorded with respect to time. So after recording such big data, whether we can do data mining or artificial intelligence. So I think I would strongly recommend all of you to do internet course of artificial intelligence. That is important. So I told you, if you can find out performance of each one, there are about 300 reactors, types of reactors, which are used, including atomic power plant. For me, any chemical reactor making kerosene or power plant, they are not different, because basic subjects are fluid mechanics, heat transfer, momentum transfer. These are the basic. The real unsolved problem is what is the physics of turbulence, which is not permitting us to design any equipment in chemical engineering from first principles. Electrical engineering, very good, voltage is equal to current into resistance. We don't have such a fundamental procedure for heat transfer coefficient, for pressure drop. We have to use empirical correlations. But you have learned artificial intelligence, you will go a couple of steps further to the reliability that you can do. I can keep on saying many things. For chemical engineers, another opportunity is project engineering, having developed the process, scaling it up. So scaling it up means what? From raw material, 100% nitrobenzene, you don't want nitrobenzene in the product. So from 100%, it is going to practically 0% or 0.01%. Right? That is nitrobenzene. There is a catalyst inside, which should remain suspended all the time. Whatever hydrogen bubbles which are forming, they should be sufficient enough and all the places within the reactor so that dissolution occurs. And then from point to point, find the performance, find the total, and find the cost. Take another opportunity. You can always assume that you know nothing. Therefore, design all 50 reactors. Economics, do it one time, do it second time. You will develop the experience. From 50, you will come to 20 to 10. And then with 1 or 2 iterations, you will be able to design successfully. Always go through hard steps. If somebody tells you, use this reactor, that is good for that occasion, but your life will be more or less miserable. And next time, if you don't get anybody, you need to wash your hands. Do nothing. I actually promised Vice Chancellor that my lecture will be interactive and I will answer a lot of questions. I think I have prepared background. I have lot many examples to say of scale up and what are the opportunities as well as cares which need to be taken in scale up. I do 4 scale ups every year. I have done 50,000 crore worth scale up in India. And the biggest fermenter of the world, I have designed. Scaled up, I should say, scaled up from 1 or 2 liter fermenter, nothing intermediate. And I can tell you so many stories. But you have heard the stories. You have heard the conclusion of my lecture, which I will repeat once more. Don't complain, don't give excuses any time in your life. Be happy, least within. Today itself, go to your mother and tell her that how much contribution you have done to my life. I'm only because of you. Tell your father. Start your happiness from there. Tell your elder brother, elder sister, whatever. Help, not help. Keep on thanking your friends also. Thank your teacher. You say to me, so your lecture was fantastic. Say it there. What goes wrong? You have to remain pleased and happy, no? So you can remain happy, and that comes by reflection and make people happy. That will make you good entrepreneur. That will make you good engineer. Finally, it really doesn't matter. You don't attach a lot of value to a particular assignment. Attach only value to the quality of your life, your own life. Whatever you like, you get opportunity, job in that direction. Otherwise, develop liking for the job, whatever you are getting. Get and understand what is your inclination. Good psychology people, they are able to understand what is your real liking, real inclination. Try to get that and move accordingly. At this stage, I will say that wish you all the best, and I'll be happy to answer any number of questions.
Yeah, please join me to thank him first. Yeah, questions? Any clarification questions you want? Yeah.
First of all, thank you, sir. I got my answer through this only.
Actually, I have been selected as best teacher of my institute for 20 years. And after my lecture, nobody asks questions. they are very clear about it. And therefore they select. I don't mean anything here. You can accept.
Yeah. Any of you?
Yes, please. Forget about my last comment.
This side? Anybody?
Sir, thank you, sir, for a wonderful talk. So it was very good in terms of how we should grow as a researcher and solve a problem. But how can we grow well as a teacher or a good lecturer? How should we inculcate those habits from our PhD tenure?
But quickly things come to my mind. Actually, whatever three suggestions I make repeatedly, no? Whenever you will meet in the corridor or anywhere, auditorium, multipurpose hall, or new auditorium, ask me anything. Ask me, where is auditorium? I'll tell you three things. Don't complain. What is next? Arey, what is next? Don't give
Be
up.
happy.
Always be happy and please all the time within. So then you will leave me in one lap. So how to become a good teacher? I think first and foremost quality required is you should sincerely think and dedicate life and time for the cause of students. This is most important. What is the present position of the student? What are the qualities that the person is having? And then what is my job to bring that person from one level to whatever level is required by either industry or academics. So when you are a teacher and thinking about this all the time, then you become a good teacher.
Okay, any other question?
Yes, thank you, sir.
You want to ask? Yeah, one more.
Just on a lighter note, where can we find you to get the remaining 48 stories that after this lecture?
Okay.
I'll let you know.
Yeah, we will plan. We will also plan such lectures. Where we stop here to start from there onwards. So that is one way we can do. Anyway, um, thank you, sir, for a wonderful talk, and I think all have mesmerized with his speech and the journey, success story, the problem you faced. Of course, the problem you faced, then the students also whatever faced. Finally, the success. So I hope the students have got the point and they find industrial problem interesting for the social cause, and they will do their research, whatever they are doing, and think, kind of application in a much more broader way in societal application. And okay, so with this, I thank you again. Please join me to thank Professor Joshi and Professor Bharati also give the talks.
Thank you, Professor Joshi. And I don't know, I was little worried when we planned this, that how many of the students will be there, and then how many will be there till end, all that. Because today the generation is changing and there is a big gap between people like us and yourself. And I'm very proud and delighted that all of you are here. And, the person who is standing there, you are all very fortunate because you are here today to meet such person in person and then discuss with him. He's a Padma Bhushan awardee, and you see his biodata that I have read: 500 publications, 28,000 citations, 84 H-index. Can you imagine? So such a person is available to you in this system. HVNI has made all your scholars to have such things. So whenever such program, please tell your colleagues, your students that you should actively, come and join in the interaction. Okay. Yes. Sir, anyway,
You are external person of it. So you will have to generate your own. Importantly, you show that you are compare the performance and share with him. If he sees, recognizing my first exercise in 1970. This is to caustic soda and chlorine. Studied the performance of these were electrolyzers in series, 50, 100 electrolyzers. But I carbon dioxide from air contributing to one more resistance for electricity. And therefore, I said that let us try to carbon dioxide. So how to do that? I put some that day, that owner appointed me as a consultant, and 52 years later, I'm telling you and imparting you that is show your right. And I was an academic job, so he never prevented. Same person, but the sent back to me. That attachment to the problem. Otherwise, I had to go abroad. I did not get ticket. Flight was delayed. I was stuck in this airport. Keep on complaining and you get nothing in life.
thank you, sir.
Internet these days gives lot of information. In 72, this was not possible, but still publications were there at that time. And plant people, they don't read. They are running after production. So use this opportunity that they don't read and you have read.
Thank you, sir. Thank you.